Okay, in this video clip, we want to trace Einstein's path to the so-called miracle year. Sometimes you'll see this in Latin, the annus mirabilis. It comes originally from 1600s, actually. Isaac Newton himself, in the about 1666, 1667, he was in London at Cambridge, and there's an outbreak of the plague. And so he retreated to his family's farm in the countryside to get away from that. During his time there, he not only really laid the foundations for his theory of gravity, he also came up with the calculus. And therefore, because of those astounding results of this really unknown person in his 20s, 20-year-old, but a little older than that, is called the miracle year, annus mirabilis, at least to science types. And then Einstein himself, 1905, so approximately 220, 230 years later, has his own miracle year. So we want to figure out how does he get to that miracle year and say a few words about the miracle year itself, why it was seemingly so miraculous. So here's a rough outline of where we're going, just some of the highlights here. We won't go into all the details because if you want, you of course can get those in the profile of the young Einstein, or maybe you've already read some of that. So this will just give you a pathway through that, reminder of some of those things. Youth in Munich. He was born in 1879, as we said in the previous video clip. His family moved to Munich when he was very young. As I mentioned in the other video clip, his father and uncle started essentially electrical business, electrical technology business, in terms of developing especially electric lighting for various cities, townships in the Munich region. He went to school in the Munich school system, and one thing to know about the German school system at the time, very rigid, very hierarchical, and had a strong sort of militaristic Prussian slant to it, and Einstein rebelled against that very, very strongly. And throughout his life, he had that sort of anti-authoritarian streak in him, and it did not fit well with him. So much so that by the time he was 16, 17, he renounced his German citizenship, and his father let him do that. And for several years, then he actually was he was stateless. He wasn't a citizen of any place. He wanted to become a Swiss citizen, but that took several years in terms of the paperwork and fees involved, and so on and so forth. So he eventually became a Swiss citizen, and then later in his life became a German citizen again when he became famous, and they wanted to claim him again, as it were. Mentioned last time also that he went to the Swiss Federal Polytechnic in Zurich, Switzerland. He actually did not get in on his first try. He applied sort of a year early to essentially get away from the Munich school system, and wasn't successful the first time. He did well in the science and math aspects of the entrance exam, but not, I think, French in particular was one of his weak areas. And so the professor there, physics professor, liked what he saw in Einstein, but said, go away for a year and come back and then try again. And so that's essentially what Einstein did, although actually the professor said, I'll even tutor you for a year if you want. But his family chose a different school to go to for a year, a nearby school in close to Zurich. That professor was Herr Professor Weber, who was the primary physics professor. There were actually two physics professors at the Swiss Federal Polytechnic, but he was the one that interacted with Einstein the most. Einstein enjoyed his lectures, at least early on, but later on in the course of study felt that Weber was behind the times, especially in terms of his knowledge and teaching of electromagnetic theory, Maxwell's equations, and things like that. Einstein's sort of impertinent attitude, impudent attitude, even touch of arrogance at times came through, because he at times would address Professor Weber not as the proper Herr Professor Weber. German educational system was very hierarchical, as was German culture and society in many places. And instead he'd just say Herr Weber, which really bordered on an insult. It was not the type of thing you would be addressing your professors as. And so in fact Weber at one point said, Einstein, you're a very smart person, but no one can teach you anything. that type of thing. And so Einstein certainly had that touch of arrogance about him in his youth, and it got him into trouble at times. In fact, a little later on here, we'll see how it got him into trouble. Also, while at the Swiss Federal Polytechnic, he met Mileva Maric, put the last name in here too, who was a Serb and came to Switzerland for its universities. Actually, many women students from throughout Europe came to Switzerland because in their homelands they weren't allowed to go to university, and so you saw many of them in Swiss universities. It was unusual, though, for a woman to be studying physics, science, and math like Mileva was. She originally was going to study medicine, then switched to physics, and that's therefore how she and Albert met. They were essentially studying to be high school physics teachers. That was the whole idea of the Federal Polytechnic. They weren't being trained to be future professors or anything like that, but the idea was that, as we saw last time with the burgeoning electrotechnological industry, they needed trained workers. How do you get those? Well, you teach them in high schools and similar schools like that, technical schools, and therefore there was a need for teachers. And so both Mileva and Albert Einstein himself were training essentially to be those types of teachers. He graduated in 1900. His grades were okay, but not great. They sort of tailed off his last 2 years for whatever reason, maybe just because he got tired of going to lecture. In fact, we know he got tired of going to lecture. He relied on some friends' notes in many cases to pass his exams. In his mid-year exams or mid-course exams, 2 years in, he did very well. Again, his graduation exams he passed, but did not do as well as he'd done before. Mileva actually did not pass, which was obviously a big disappointment to her and to him to a certain extent. So the graduation in 1900, and then the idea, of course, got to get a job. In particular, he was hoping to get a job so he could marry Mileva, which caused a lot of tensions. I have career anxieties here. There are also a lot of family anxieties. His family did not care for Mileva for a number of reasons. She was Serbian, for one. Secondly, she was very short, not conventionally attractive, 5 feet, maybe less than 5 feet. She had a congenital defect in her hip, so she walked with a limp. So therefore, the question of her soundness as a wife came into play. His mother had another favorite among his earlier girlfriends, etc., etc. So there's a lot of family tension at this time, and of course, Einstein's own impertinent tendencies came into play as well. As far as his career anxieties here, what he was really wanting to do was get a position as a physics assistant, perhaps with Herr Professor Weber, helping him out in the physics labs in training of future engineers and things like that, or with another university. Unfortunately, probably because, or at least in part because, he had sort of antagonized Professor Weber, he couldn't get a position any place. He had the suspicion that Weber was sort of bad-mouthing him to his colleagues in various places. And even though he applied to essentially universities all over Europe, nothing came up. And in fact, there's a very poignant letter that, unknown to Einstein, unknown to Albert, his father wrote. He wrote a letter to a professor at the University of Leipzig. It was Professor Wilhelm Ostwald, a very well-known physics professor. And here's what his father, Hermann, wrote to Professor Ostwald. He said, "Please forgive a father who is so bold as to turn to you, esteemed Herr Professor, in the interest of his son. I can assure you that he is extraordinarily studious and diligent and clings with great love to his science. My son, therefore, feels profoundly unhappy with his present lack of position and his idea that he has gone off the tracks with his career and now is out of touch. This feeling gets more and more entrenched each day. In addition, he is oppressed by the thought that he is a burden on us, people of modest means. Since it is you, highly honored Herr Professor, whom my son seems to admire and esteem more than any other scholar currently active in physics, it is to you whom I have taken the liberty of turning with a humble request to read his paper published in the Nachrichten für Physik, and to write him, if possible, a few words of encouragement so that he might recover his joy in living and working. If in addition you could secure him an assistant's position for now or the next autumn, my gratitude would know no bounds. Again, Albert did not know his father had sent that, as far as we know. But you get some of the feeling coming through there. It's also, Herman, his father, mentions being people of modest means. They actually had been fairly prosperous, but in the 1890s, their electrotechnology business hit some real bumps. They lost a key contract that they were vying for, and therefore went bankrupt in 1894. Tried again, went bankrupt in 1896, and therefore it really weighed on Einstein, perhaps even more than his father, who was sort of more of an optimistic sort. So a lot of these things were weighing on Einstein at the time. The career anxieties, the family anxieties, the rift with his family in terms of his relationship with Mileva. No record exists of response by Professor Ostwald to Hermann Einstein's letter on behalf of Albert. What's ironic, however, is just a few years later, in fact 9 years later, this was written about 1901, 9 years later, Ostwald was the first person to nominate Einstein for a Nobel Prize. So he may not have even read the letter, who knows, he may have read it and just tossed it, but within 9 years, Einstein was definitely on Ostwald's mind. So definitely career anxieties at this point in time. He was looking for a position as a physics assistant, perhaps. He thought about tutoring, teaching position in a high school someplace. And a friend of his came through for him. After about a year of this, a friend in need, a friend named Marcel Grossman, who actually had helped him graduate, because Marcel Grossman actually went to lectures and took notes that Einstein could then use. Einstein spent a lot of time tinkering around in the laboratories. He enjoyed that more than many of the lectures. Well, Marcel Grossman's father knew the head of the Swiss Patent Office. And again, the whole context here of this revolution in electrotechnology, and really, if you think about it, the last 20 or 30 years, there's an analogy with the computer industry in our time, providing a lot of opportunities. And in this case, the patent office needed to expand. They're getting more and more patents in electrical and technological fields, and so they were going to add a position. Einstein wasn't quite perfectly qualified for it, because the best training would be, say, a mechanical engineer, but his physics training allowed him to qualify, and he certainly knew electricity and magnetism very well, that part of it, and they felt they could train him. So essentially, that opportunity opened up, although it took a little while before he actually got the position there. So that was about 1901. In celebration of this, Einstein at that time was actually in Milan, Italy. His father had moved the business from Munich to Milan because investors in business thought that the Milan area would be a better area for developing a new business. They were selling generators and things like that by that time. So he invited Mileva, hey, let's go for a nice weekend together to celebrate. They met in northern Italy at Lake Como. Mileva was still in Switzerland at the time. She was studying for another year to try to graduate. They met there, had the great romantic weekend. They talked about, going on a boat up Lake Como and over the Splugen Pass on this sleigh with snowdrifts, on either side of them, and so on and so forth. So a lot of lasting memories that Mileva wrote about to a friend. A few months after that, another lasting memory came along because Mileva discovered she was pregnant. And as you might imagine, that added even more to the anxiety and turmoil that Albert and Mileva are feeling at this point. And so there's a lot of zigzagging at this point in terms of what Einstein felt he should do. Sometimes he would say, he'd write to Mileva and say, I will look for a position immediately, no matter how humble it might be. So he actually considered going into the insurance industry. He applied for a position teaching just physics in high school. He applied for another position teaching essentially mechanics and machines and so on and so forth. So he was just trying to find anything, because even though we mentioned his friend, Marcel Grossman, had an in the patent office, that position hadn't actually been advertised yet. There was a long delay here. And finally, though, all the zigzagging ended because the patent office position did open up. The head of the patent office actually wrote personally to Einstein and said, please apply for this position. And finally, it came through, and that would be in about 1902. So there's about a 2-year period from when he graduated to 1902 with turmoil, a lot of anxiety in his personal life and his professional life. He was able to continue to do some physics. And in fact, also in 1902, when he was then at the patent office in Bern, Switzerland, a couple of his friends, and he put together what they called, sort of grandiose terms, the Olympia Academy. Essentially, they got together and they read books together, a lot of works in physics, but also philosophy, literature, and they would read and discuss these books intently and intensely for hours at a time, and also play some practical jokes on each other and things like that. So he certainly was still doing some physics. He'd actually been able to publish a few papers along the way, but he essentially was out of academics, and just anybody looking at him at that point would say, it's nice he has that secure position in the civil service, in the patent office, and maybe can keep doing a little physics on the side, as it were, and discuss it with his friends in this informal Olympia Academy they had. Mentioned the pregnancy back here. A daughter, Liesl, was born. We don't know actually the formal name given to her, and actually we don't know what happened to her. There have been, once this did not come to light until about the 1980s or so fairly recently. It was not known during Einstein's lifetime itself. And there's some evidence that she might have died at a fairly early age, maybe about 2 years old, of scarlet fever. But there's no definitive evidence exactly what happened to her. Some people think maybe, again, she was adopted by friends of Maleva's family. Whatever, what we do know is that Maleva joined Albert in Bern, Switzerland, when he got the job at the patent office, and Liesl was not with them at that point. And clearly, just reading between the lines in some of the accounts of Maleva's life, it affected her profoundly and had implications for their later lives as well. So finally, then we come to the miracle year. Miracle year of 1905. Again, you would not look at Einstein's life here. Certainly, he was a good physics student. Look at his career so far, and this would be totally unexpected that this would happen. He had been able to publish a few physics papers in German journals, but nothing extraordinary. So let's just take a look at the miracle year itself here and talk about, briefly, the 5 papers that he published in the miracle year. So finally, then, we come to the miracle year. Miracle year of 1905. Again, you would not look at Einstein's life here. Certainly, he was a good physics student. Look at his career so far, and this would be totally unexpected that this would happen. He had been able to publish a few physics papers in German journals, but nothing extraordinary. So let's just take a look at the miracle year itself here and talk about, briefly, the 5 papers that he published in the miracle year. So, March 1905, and we're just going to give a brief summary of each. Obviously, one of them, the one that dealt with what became known as the special theory of relativity, will be our focus in this course. But in March 1905, he published a paper that essentially introduced the idea of the light quantum. So this was one of the seminal papers in quantum mechanics. And of course, the theory of quantum mechanics came to dominate much of physics throughout the 20th century. And Einstein was there at the beginning. It was what he called a heuristic proposal, because you might say, well, what is a light quantum? Essentially, it's treating light as a particle. But you think, well, what about the wave theory of light? That was well established by this time, 100 years or so after Thomas Young had proposed more modern wave theory of light. Earlier versions had existed as well. So here was Einstein going back essentially to a discredited idea. And how can you have light as a particle when the wave theory of light was so well established? Well, he said, I know all that, but you know what? The wave theory of light really deals with light as it's traveling. We're not quite sure what happens when something emits a wave of light, a light wave, or absorbs light. And so this is what he was dealing with at this point. And he essentially called a heuristic proposal. He said, let's just try it and see what happens. And he was able to, using this idea, was able to show that some experimental results that couldn't otherwise be explained were explained by his idea. So the idea of the light quantum, that's in March. Next month, April 1905. This is all 1905, so I guess we don't need to put the years, but we will. April 1905, published a paper that actually became his doctoral dissertation. This was his essentially at least a second attempt at a doctoral dissertation. He had a couple other attempts that never got anywhere. And of all the papers that he published in 1905, this is maybe the most, you wouldn't call it ordinary, maybe mundane, but it is a paper demonstrating that you could actually calculate the size of molecules. Other people had done similar calculations. He came at it from a different direction, and through some fairly sophisticated calculations was able to demonstrate, for example, the size of sugar molecules suspended in water. Came up with a theory of how to do that. This actually became the most cited paper of all of them in 1905 because it had many practical implications in terms of just any time you have grains of things or solutes in solvents and so on and so forth. So size of molecules, good solid paper, not revolutionary, but certainly influential within its context. So that was April, just 1 month apart. Now we get to May, the next month. Any one of these papers would have been a good paper just for a year's output, but he's now in May 1905. And what he does is publish a paper that for the first time provides really good theoretical proof of the existence of atoms. And it came about because he was able to explain a phenomenon known as Brownian motion. Brownian motion goes back to a guy named Brown, actually, in the 1820s, 1830s. And what the observation was that if you take maybe dust particles or pollen particles in water and you look at them under a microscope, the particles sort of jiggle around. They zigzag. And the question is, early observers who saw that thought that the particles might actually have some sort of vital force in them. They're actually some sort of organic force going on. But Brown and others were able to show that it really happened no matter what it was. You can put rocks, little bits of rock and sand and so on and so forth, and you still get the same effect. And it came to be called Brownian motion. So the question is, how do you describe something like that? What's going on? And what Einstein was able to do, using actually some of the techniques he developed in this paper on the size of molecules, where he imagined sugar molecules, larger sugar molecules suspended in water among the water molecules. He applied that to Brownian motion, some of those same techniques. And so you've got the pollen particles being the larger entities there within the water or whatever. And he applied some hydrodynamic theory and so on and so forth. And essentially came up with the idea that the motion of these particles that you could actually track. So you would actually look at a little particle here and you observe it over time. And it'd be over here, and then maybe over here, and then there, and then over here, and so on and so forth. And you sort of get what later became known as a random walk. And Einstein developed a theory that explained that and also was able to sort of put it together in a way that became very easy, or relatively easy, for experimentalists to try to verify that. In fact, right about this time as well, a couple of years before this, the so-called ultramicroscope was developed, which allowed people to really about 50,000, there's an increase of 50,000 times or so in magnification. And they were able to apply it to the Brownian motion problem. And within a few years had demonstrated that, yes, Einstein was right. And so, whereas you might think, well, people had talked about atoms forever. In fact, going all the way to the Greeks, going all the way back to the Greeks, people had talked about atoms. But even at this late date, this is after the existence of the periodic table of the elements developed in the later 1800s, and John Dalton's atomic theory earlier in the 1800s, and so on and so forth. There was still a lot of skepticism that atoms actually existed, and in fact, whether they were even a proper entity to inquire about for scientists, because you could never see them. How could you ever imagine to see something as small as an atom? So maybe we shouldn't worry about atoms themselves, but look more at the bulk properties of matter and seek to explain that way. Well, Einstein actually was able to show theoretically that there was pretty convincing proof atoms existed. It was backed up a few years later by experimental proof. And here's actually where Ostwald comes into our story again. Wilhelm Ostwald, who we just talked about, Hermann Einstein's letter, Albert's father, letter to Professor Ostwald. And he was one of the holdouts. He was a very strong skeptic of atoms. And yet Einstein's work, plus the experiments a few years later, convinced Ostwald. So he had a very well-known textbook on physical chemistry. And as late as 1905, 1906, 1907, he was still saying, there's really no good evidence for the existence of atoms. By, say, the 1908, 1909 edition, he changed his tune on that. So, May 1905, that paper, Existence of Atoms. Now we're into June 1905, and this is the paper on the special theory of relativity. It is actually, the title of it dealt with the so-called electrodynamics of moving bodies. We will actually be looking at that paper. I'll have you read it if you're doing the more quantitative approach to the course, to read it, not to try to understand all of it. Actually, the physics and math involved isn't that complex, but it is beyond, some of it at least is beyond our course. But, and if you're doing the qualitative approach, it's optional if you want to read that. But just to get a sense, what's his argument here? What are the sections? Outline the paper, see what he's trying to do here, and then we'll talk later on a little bit more about the details there. So the electrodynamics of moving bodies there, special theory of relativity in June 1905. And there's a famous line here. Einstein had been thinking about this for a long time, and there's a key contradiction that he just could not get his mind around. And again, we'll talk about the details later on. But he had a friend at the patent office named Michael Besso, and they often would go out during lunch break. He worked at the patent office 6 days a week, 8 hours a day, had a lunch break there as well, so 9 hours if you include the lunch hour. They'd often go walking and talk about the latest physics problems that Einstein was thinking about, and Besso as well was trained as an engineer, and he and Einstein had known each other for a number of years. And so they're talking about some of the conundrums, some of the puzzles involved in this, and the whole electromagnetic worldview we talked about a little bit. And finally, something Besso said. We don't know exactly what he said, but the next day Einstein came back and said, I have it. Essentially, what you said, cleared everything away, all the cobwebs away, as it were. And in later years, Einstein described it this way. He realized that time is suspect. There's something about the nature of time itself that he and a lot of other people had overlooked. And so that will be one of the key things we'll be investigating, this whole idea. What does it mean to say time is suspect? Why is time suspect? That's June 1905. And as we're doing this here, as we're thinking about this, don't forget the context here. He's working in the patent office. This whole idea, time is suspect, every day almost. He's probably reading patent applications dealing with time. and dealing with telegraph signaling systems and the synchronization of clocks was a huge issue at this time. So there's no direct connection necessarily between the expansion of the railroads, telegraph, synchronization of time, standard time zones, and all that. Yet it provided the context, and perhaps it was something unconsciously that led him to these insights, as well as a number of other factors coming in there. So that's June 1905. Then one more paper in September 1905. And essentially this is an addendum, a coda to the June 1905 paper. He says, I've been thinking more about that paper I wrote a few months back. And there's some interesting implications of that. And essentially, the key one is E equals mc squared. Einstein didn't quite write it like that, but that's essentially what it is. Energy equals mass times the speed of light squared. Most famous equation, certainly in the world, and really just sort of a tacked-on paper to an earlier paper here. So, definitely the miracle year. This unknown 26-year-old patent clerk, seemingly out of nowhere, comes up and publishes 5 papers that any one of which could have made his career, certainly, in the physics world. And yet, in a real sense, certainly the light quantum paper, the special relativity paper, the E equals mc squared paper, the existence of atoms paper, these had profound implications for how we understand physical reality. And even the size of molecules paper, certainly, as I mentioned, most cited paper of all of these, and it's one of the most cited papers of its time. So an astounding year. And yet, even though all of this happened, later on in the course we'll say, how did people receive this? Especially, how did people receive this idea of what became known as the special theory of relativity? And it was a mixed result at first, a mixed reception. In fact, there was strong evidence right off the bat that the theory might be dead on arrival because there were experimental results that said it was false. And so later on in the course, near the end, we'll look at that, see how Einstein responded to that, and see what happened in later years after his miracle year, which certainly rivals Isaac Newton's miracle year for its miraculousness, I guess you could say. So hopefully that gives you now an idea of how Einstein came to 1905, some of the key trends we see in science and technology of this time, and then Einstein's own particular context, despite being in sort of a turmoil with his family, with his girlfriend, getting pregnant, jobless, wondering if he's able to find anything, still is able to persist and persevere and show resilience and grit, in a sense, and focus in on his physics, that those powers of concentration. So this did not come out of nowhere. Sometimes we think miracle year, and we talk about like 5 papers in 5 months. So he just started thinking about perhaps in January, and all of a sudden this poured forth. No, this was a long period of preparation. He'd been thinking deeply about a lot of these matters for a number of years, certainly since the mid-1890s. So for at least 10 years, he'd been working on these things. And it was just the way it worked out. The insights sort of tumbled out during this year of 1905. So what we'll be doing next then is, and really for most of the rest of the course, is looking more specifically at the special theory of relativity and trying to understand it sometimes in a quantitative sense, but certainly in a more qualitative sense as well, so that we can follow in the footsteps of Einstein. And really, as we started the course with the idea that just to peel back a little bit of the mystery of the marvelous structure of reality, as Einstein put it, and as Einstein sort of showed us the way here.